Alright, good evening class. Going over section 6.1, we're going to look at classifying quadrilaterals. So quadrilaterals are just a four-sided figure, so we're going to start there. So as we get going, the first thing we're going to go ahead and look at is the types that we have. So first of all, we have a parallelogram, which is a quadrilateral with opposite sides that are parallel. So anytime you see this today, you're going to see that means parallel. Okay, so a rhombus is a parallelogram, two sets of parallel sides where all the sides are equal. So a rhombus is a parallelogram. You go to the next one, you have a rectangle. Opposite sides are congruent. It has four right angles and opposite sides. So it's a parallelogram, opposite sides are parallel. It has four right angles and then opposite sides are also congruent. You have a square. A square is a parallelogram, four right angles, and now all the angles or all the sides are equal. So if you look at it, in a parallelogram, underneath a parallelogram could be a rhombus, a rectangle, or a square. So let me skip through this. Next, we have a kite. A kite, when we'd say adjacent angles or adjacent sides are equal, and you have no sides that are parallel. And so opposite sides aren't equal. So if they were congruent, then they'd be parallel, which that means you'd have then you would be looking at something else. You'd be looking at potentially like a rectangle, or we call that a parallelogram. We go to a trapezoid. Trapezoid is one set of parallel sides. If it turns out that you have two sides that are congruent, then we call it an isosceles trapezoid. So one set of parallel sides. So those are our shapes that we're going to be working with today. We're going to first look at classifying them. So just by looking at it, what would this be? Well, it looks like a square, so we call it a square. But it also could be a rhombus, because it's opposite side. All the sides are equal, and you have opposite sides that are parallel. Then you have a rectangle, which opposite sides are congruent, which is the case. And you also, and they have four right angles, and you'd also look at it and be a parallelogram. So you could label all that as well as a parallelogram. Here, looks like if you said these sides looked equal, you could say that's a rhombus. If they don't look equal, they just look like opposite sides are parallel, then we'd call that a parallelogram. So you could call that, I could see it calling a rhombus. If you didn't think these looked equal, you could call that a kite, but just remember that a kite, the opposite sides can't be parallel. They can't be congruent to one another. This here looks like a trapezoid. If you look at these sides look equal, so we call it isosceles trapezoid. So now you go here. We want to determine the name that's most precise for this. So if you look at it, it looks like a trapezoid. Okay, a couple things we have to look at then if you look at here, then these lines need to have the same slope. So we check the slope. If you went ahead, you check the slope. So you check the slope of it, you get 0. You check the slope here, you get 0. So you do have parallel sides. So just remember how you find slope, subtract the y values, subtract the x values. Rise over run, so y over x. The other thing so you have a parallel side, so that's a trapezoid. The other thing we're going to check is if the C, so if I go back to my picture, I'm going to check to see if these sides right here are congruent to one another. So I'm going to see if BQ is equal to HA. So we come here. So we want to see BQ, so we want to find the distance. So subtract your x values, subtract your y values, square them. So that's how we find distance. Subtract your y, subtract your x, square them, and then add them together, find the square root. So come here, we'll just leave it as a square root of 29, estimated out 5.3, 5.4, somewhere in there. Do the same over here. Subtract your x values, 8 and 10, subtract your y values, 9 and 4. Square them, so 2 squared is 4, negative 5 squared is 25, and you get 29. So if you look at it, those sides are congruent. So you have opposite sides that are parallel, you have the other sides are congruent, we call that isosceles trapezoid. So that would be the most accurate way. Then we come here in a parallelogram, parallel sides. So again, this side is parallel to this side, so R and S. So if these sides are parallel to one another, then they're same side interior angles, so they sum to 180. And so we go ahead and state that. These two, 2x minus 10 plus 3x plus 5 equals 180 degrees. Add that, go ahead, combine like terms. 2 plus 3 is 5, negative 5 plus 5 is negative 10 plus 5 is negative 5. And so you get x equals 37. So we want to find the measure, so that found x, we want to find the measure of s. So we plug it in. 2 times 37, 2 times 37 is 64. 2 times 7 would be 7. 2 times 37 would be 74. Minus 10 gives you 64. So s is equal to 64. Okay? If you had something classified as a square, what other classifications could you call that? You could call that, again, rectangle, rhombus, parallelogram. Any of those would work. And quadrilateral, four-sided figure. 2 more examples. Find the values of the variables for the rhombus. So if you think about rhombus, what do we know about all the sides? They're all equal to one another. So I could come here and I could say 5a plus 4 equals 3a minus 8 and solve. And so that's what I do, is I group them up. We can solve for b. Right here, subtract 3b, add 2, b is equal to 4. Come over here, subtract 3a, subtract 4, a is equal to, subtract 3a gives you 2a, a is equal to 2. And last example, you have a kite. So what's our definition of kite? Well, congruent or adjacent sides are congruent. So this right here is equal to this, and this side is equal to that side. So we go ahead and state that. Now I'm going to solve for this one. You have x. This one right here, I have 2 variables. So I'll solve for x here, subtract 2x, add 5, so x is equal to 9. So then I would plug in 9 over here. 9 plus 6 is 15. Subtract 5, divide by 2, y is equal to 5. So that's just a real quick synopsis of what we're going to go into. So we're going to look at figures, more what people think about when they look at geometry.